Welcome, everyone. I'm Catherine Lawrence. I'm with the Science Gateways Community Institute, and I'm really delighted to have you all here, especially to hear from Mark Miller, who is not only a terrific member of our community and a scientist, but also a member of our steering committee for Science Gateways Community Institute. First, I'd like to just go over a little housekeeping. And we are in webinar mode, as you might have noticed. And so your audio and video are off, but we can unmute you if needed to clarify a question. You are welcome to submit questions at any time using the Q&A section at the bottom of your screen. And we will, I'll pass them along to Mark when they come up at an appropriate time. You also can use chat if you're having any trouble with, audio or other questions that aren't questions for our presenter. And we're recording this, so those slides will be available along with the recording at the end of, probably by the end of this week or sooner. So I'd like to just tell you a little bit about the Science Gateways Community Institute before we get started, if you're new to our community. We are funded by the National Science Foundation to provide support to Science Gateways in several different ways. And we group these into the three areas of support for building and running gateways, education and training, and networking and community. I'll tell you a little bit about each of these. So in the area of support for building gateways, we provide hands-on development support, which is a programmer who can actually help build your gateway or add a feature. We also offer consultants who can provide advice about things like usability and cybersecurity and graphic design and sustainability, a number of different topics. We also have a catalog of gateways and software, which I encourage you, if you have a gateway that's not already listed in the catalog, to go and add your item to the catalog. It's both gateways that are available for use in various disciplines, as well as software components that can be used to build gateways. Now, in the area of education and training, we have a number of different things that we do, including this webinar series. We also offer Gateway Focus Week, which is an intensive opportunity to learn from several of our consultants about things like sustainability and marketing and thinking about your audience. As I mentioned on the first, as you might have seen on the first slide, our next Gateway Focus Week is scheduled for November, December, and we are accepting applications. And at that point, as we get closer, we'll determine what format it will be in, virtual or otherwise. And we also offer a number of student-focused programs, including a summer coding institute that just ended, an internship program, and workshops during the year. And do visit our website. And then finally, we are all about building community, and we have an annual conference, which is going to be in mid-October. That registration will be opening most likely next week, so do look for the announcement about that if you're on our newsletter list, or check our website. We have a community forum, which is a Google group where anybody can post questions or get information resources from others. We have 2 ambassadors programs. The Gateway Ambassadors Program has a monthly meeting that is lively, and the upcoming one, it's always on the first Thursday of the month, and they do all sorts of brainstorming and sharing of interesting programs. And then we also have a Science Ambassadors Program, which is to help promote gateways and their use within various scientific disciplines, and that is on a rolling admissions basis with review at the end of each month. So if you're interested in getting funded for either open access publications, presenting at an event, or offering some kind of training, go check that out. And finally, we have an affiliates and a partner program where you can we can work with you to both promote and share resources of ours and yours. So with that, I just want to offer one last request, which is that it helps us to get your feedback. So we will be posting this link during the webinar in chat, and before you leave, we hope you'll provide your feedback about this webinar, and also it gives you an opportunity to suggest other topics that you might want to hear. So with that, I will let Mark start sharing his screen. So it's my pleasure to introduce Mark Miller, who is from the San Diego Supercomputer Center at UC San Diego, and he is joining us from vacation land in Tahoe, Lake Tahoe. So, and I told it I would out him on that because he's not going to have his video on. So you won't get to see him speaking, but here he is for real, talking about the CIPRES Workbench.
Well, really, it's kind of a blessing to turn off the video for you all. You don't have to take the blow. Anyway, it's really nice to be here this morning from lovely Lake Tahoe. There's a nice meteor shower going on right now. If you all haven't noticed it, the Perseid meteor shower is going on. Anyway, but I'm not here to talk about that. Today I'm here to talk about the CIPRES Workbench, which is the framework that underlies CIPRES and a couple of other gateways. And for my talk today, oh, I'm not advancing. What's going on?
What's the concern?
Okay,
oh,
sorry, I had trouble advancing. So the outline of the talk today, I'll spend a few minutes on an introduction and give you the context in which we created the CIPRES Workbench Framework. And then I'll review some of the features and some of the architecture. We'll just touch on that. And then I'll go over what it would take to create a workbench from the CIPRES Workbench Framework. And then talk about why you might want to use this particular platform in the context of all the other options that are out there. So in the beginning, you know, science gateways have existed for a long time now, but they weren't always called gateways. That's a relatively new term. But CIPRES became a gateway, I think, in 2009. Anyway, but you know, here's some screenshots of just some biology science gateways, and they're very widely popular and very useful for delivering content. And I think this audience is probably well aware of this. And when I started building a gateway, you know, the running idea that I had as a biologist coming to software development is we could create one generic infrastructure that would meet all the needs or requirements of any gateway community. And so we could easily create gateways with a minimum of effort. And as I gained experience, it became clear that the devil is in the details, and I think a developer could quickly have seen that. There are many different requirements, and not all of them are easily met by a single infrastructure. And with that acquired wisdom, CIPRES, no single software package is enough. We really need a software ecosystem that will meet the needs of all the various different communities that need to be enabled. In the original approach to gateway frameworks, the generic type, the idea was to create a distributable generic open source software package that could be installed locally on a server or perhaps a whole cluster, and has a flexible and scalable and configurable tool set, and that distributes jobs or database queries or both to the local cluster or to remote compute resources and or databases. And you know, the general characteristics of this are, you know, a customizable HTML or JSP front end, a configurable or customizable middle tier, and then support for job submission to a local cluster that the package runs on, or making database queries to outside resources or local resources. And so the gateway creator has responsibility for everything in the box, you know, and each new gateway created requires, you know, that that the creator have responsibility for those things, and perhaps the resources as well, but perhaps not. And a number of platforms use this approach, and the three that I'm most familiar with are PubZero and Galaxy, and our CIPRES Workbench Framework. These all have, even though they're similar in their intent and in their design, they have very different features, and they serve different kinds of communities and community needs. For example, the PubZero platform is a very rich kind of social interface, more interactive within a community. It's like a community platform. It was designed initially to be on a single cluster and to run very relatively lightweight, not computationally intensive jobs. Similarly, Galaxy was meant to run on a single cluster and would be installed on the login node and would submit jobs to the local cluster. And since that time, both of these platforms have been modified and adapted to submit to exceed resources and others. The CIPRES Gateway, on the other hand, was strictly created to serve parallel codes on exceed resources, or then TeraGrid resources, to the phylogenetics community. And so our platform was built strictly for delivering command line instructions to high performance compute resources. So the idea, the concepts of run efficiency and controlling access and those kinds of things were very important from the very beginning. But stepping back to the general architecture, the pro of that is, you have responsibility, you have control of everything in the stack. So you're not building dependencies on things that might go away. And for us, that was a big plus, but there weren't a lot of other options at the time when we built this. And the con is that you have complete responsibility. So you need a team or access to expertise in interface and middleware. You need HPC expertise to maintain operations. And then, like, each time you build a new one, the overhead for setup is similar, so you don't get a lot of leverage, but you have control. So that's the trade-off. PubZero has at some point introduced a variant of this approach where they have a fee-for-service model where they can provide a working instance with software and support and maintenance. And it's highly customizable for your individual community. And this can be set up and maintained for less than the annual cost of the developer. So that's an interesting variant on this model. And then there's a more recent approach that's appeared. It's not that recent now, but the concept out of TAC, the Agave API, and Marlon Pierce at IU and Suresh Maru have created the SciGap project, the Aravada infrastructure. And the concept there is slightly different. And the idea is to create a set of generic infrastructure services, middleware that any gateway is going to need, and that can be consumed by any gateway and multi-tenanted, so you can build a new gateway as a client to consume these services with them providing middleware as a service and providing the expertise. So you have that part of the stack maintained for you. And so just a simple representation of that would show the gateway creator is now responsible perhaps only for the interface and the database. And in some cases, the service provider will provide you a generic user interface client, for their infrastructure. So you may not even be completely responsible for that, but for adding the domain content and that kind of stuff. So that's a considerably lower overhead for initial installation and creation of a gateway. And again, the middle tier then provides you connectivity to the various resources that your gateway is going to require. And there are platforms, as I mentioned, that support this, the SciGap project, aka Aravada from IU, and the NERSC web toolkit called Newt is similar, and now The Agave infrastructure API has been replaced with Topis, as I understand, and all of those are providers that offer that kind of approach. And just to look from the outside at the pros and cons of that particular approach, the pros are sort of what I mentioned. You have responsibility for the interface only. You have experts maintaining your middleware. The overhead setup is less, and middleware and HPC expertise may not be required. And the centralized resources lower the cost per gateway. And the cons of that are you do have a dependency on an outside provider, and it depends on the stack and the infrastructure and the staffing provided. You know, will those things actually meet all of your needs? Will the API be stable? Will the API be rich enough? Can I access these private resources? My own private resources easily? And will the service provider provide good response time when issues arise? And so those are all sort of conventional worries about building a dependency on another group. And it's pretty clear that of the ones that I mentioned, there's certainly a number of very successful gateways that are built on that model. So obviously the answer to those is, in many cases, the pros outweigh the cons. And so that's just sort of an overview. When we started this, those kinds of architectures were not available. And so just describing the intent of our software, I think software kind of has a bones that it's built around, and it's good to know what's the intention of the software and what's fundamental to its architecture. So I'm going to try to cover that a little bit. The design began using Java Struts 2 in 2004 or 2006, and the key intentions were to submit jobs to remote HPC clusters, as I mentioned, to offer a scalable toolkit. So we want to be able to add tools quickly, and we want to be able to expose all the command line options for any given tool. And those were user requirements. Those came to us as requirements. And then, you know, the software is designed to create and deliver command lines and submit scripts to remote HPC clusters, and to automatically optimize for efficient running based on individual data set properties on a code-by-code basis. So, you know, because we're running parallel codes on HPC clusters, you can get very efficient or very inefficient use of resources, and it requires a kind of an expert system. And our users did not have that knowledge. So the ability to automatically optimize those things has always been the key deliverable. Another deliverable was submitting, a desired deliverable was submitting queries to remote databases, and the infrastructure does allow that. Okay. And I thought I'd just tick down a list of things just to provoke people's interest. You know, just in case one of these things or another particularly interests you, we can follow up on it. So users configure commands through a web form. They don't have to know anything about HPC systems. It's just a point and click interface. And that's the design goal. Users have access to all the relevant command line options for any given code that we offer. And job submissions to and results returned from any arbitrary cluster. Currently, we've built out infrastructure that would allow us to create a Slurm instance in AWS, so we can have a full-on meta scheduler and submit jobs just about anywhere that will always have a good uptime. We're not currently using that, but that feature is available. Again, I mentioned automatic job configuration tailored to the submitted data sets. Submitting to clusters based on job properties or queue depths. This is a new feature that I'll talk about for a few minutes. But that's a new thing for us, being able to submit based on what's happening in the queues now. The ability to restart checkpointed jobs, or users run codes that can run, we have a special dispensation to run for a week, which is very unusual on an HPC cluster. but that's not even enough for many jobs. So the ability to restart a checkpointed job and not lose the time, that's a feature. And then automatic retries. If the host should turn up to be unavailable when a user submits a job, their submission will be automatically retried. And then, of course, when providing access to resources, the control issue is there. We need to be able to control resource consumption, and that's been built in. Recently, we implemented data sharing via the CME-Lab project, so our user interface is now integrated with the CME-Lab. There's administrative interface, obviously, to manage user registration and user jobs and to monitor queue situations. So, and then most of these features are available through a RESTful interface. The current package that we're using we're not actively using remote database queries. And a con of our architecture is we don't easily support tools requiring any kind of interactive graphical interface. So it's built on the concept that there's some basically countable number of command line options, and we can support those. But if you get into complex tools like R and MATLAB that are the next step is highly conditional on the last, and the command line options are enormous. That's not a good use case for us. As I mentioned, there are other gateways that are using the CIPRES Workbench Framework, and those include the NeuroScience Gateway. And they've added the ability for their users to compile their codes, as part of their submission, and that's a requirement of their particular user base. And they've also built tools to support cloud computing on Jetstream that I use. So, and then the COSMIC2 Gateway is a Cryo-Electron microscopy gateway, and it supports Globus integration now because their data sets are in the terabyte range, whereas our file movements are typically done by HTML. Globus allows them a more robust and restartable and better mechanism. And we're working on getting all 3 projects now working from the same code base, because all those features are very useful and should be configurable. So just to look basically at how CIPRES operates, is operating currently. We provide access to Exceed and other resources, both through the browser and through the REST interface. So the user can access it through a desktop or another gateway even as the client. And then we'll send parallel codes to Exceed resources and serial codes to try. And this is just a more slightly generic representation of that. You know, you have the option of using the RESTful interface or the browser. And as I mentioned, the client can be a desktop app or another gateway, and submitting to arbitrary execution hosts. Okay, so just to review, the goals are a basic workflow for job submission to HPC clusters, easy to add and update existing tools, a stable environment for results and data storage, and a simple user-friendly interface. So just to go through the basic architecture that we use, there are 3 basic job creation concepts in the package. There's data, which is user-created input for any given task. There are tasks, which I'll occasionally call jobs, and I apologize for that, but formally we call them tasks. And tasks are made up of 1 or more runs, and any run is a submission to the scheduler of an HPC resource. So a task can have multiple runs. As I mentioned, some of our codes support restarts, and so that concept is important. And just to sort of go through the workflow that the user would follow, typically the user will upload their data And at that point, we need to parse the input files to extract metadata to help configure the run efficiently. And that was added because we found that asking user standard that information was very error prone. And sometimes we end up with very inefficient job runs. So step one, the user uploads their data, and when it arrives, there are scripts that determine which format the uploaded file is. So it's either recognized format or not recognized. And if it's recognized and relevant, in other words, it contains information that's useful for configuring the job run, it'll go through a parser, and information will be extracted that's relevant to the job run. And these are domain-specific scripts, so they'd be created new for each different implementation of CIPRES. And then that's stored in a database with the attached metadata for later use. And then if the format is not recognized, or if it's recognized and not relevant, we can bypass parsing altogether and just store it, because there's no useful information for configuring job runs there. And we do this on upload because it would be like super annoying to wait for the file to be parsed while you're actually trying to construct and submit a job. And just to go a little further down on that, like determining the format, this is an example. There's Beast1 and Beast2, two different codes that we offer. And when they're recognized, Beast1 is treated differently than Beast2. Beast1, the file itself contains enough information to effectively configure the run. And so it's parsed with that script. And then the metadata is attached. And then for Beast2, however, for some reason, they decided not to include some of that information in the actual file. So we have to pre-run that first on the server and then parse the output of that run. So we run it for like 2 minutes and get what we require, and then look at the standard out and find the metadata and attach it to the data set. All right. And so step 2 would be the job creation. And the user experience of that is going to look like you select data, your data, and select your tool. And if the tool and data match, in other words, we know the tool, we know the data format. Typically, the tool may specify that it requires a certain data type. And if those two match, it's validated. The user can configure their job run via a web form, and then the attached metadata is loaded when the job web form is presented to the user. So the user has the option of changing with the preloaded values, but they're discouraged from doing that. And then there's a JavaScript validation step, a submission, and then a check to see if the user is actually allowed to submit based on other criteria that I'll talk about. So that's the basic user experience. And just to go in now into step 3, the validation step, looking at this schematically, the users, as I mentioned, interact with web forms. They configure their jobs. There's a couple levels of validation. As I mentioned, the web forms are pre-populated with metadata from the parsers, if there is any. And then JavaScript enforces rules in the web browser that allows the user to configure certain options in certain ways. And the intent there is to prevent the user from creating a job that can't be run successfully. And then the user will submit. Then it goes to the SDK. And on submission, the job is validated in the SDK. A file called scheduler.conf is created, which configures the job when it gets to the execution host. And any additional files that are required for the run, many different codes require auxiliary files. Those are created as well. And all are then entered into the database for tracking. And the application also checks to see if the job's going to violate user submission limits. We track how many CPU hours, or SUs, if you will, an individual has used within a given allocation year, and if they exceed that amount, their submission will be halted.
Mark,
And
there's a question that just came in from Mona. She said, can these parsing scripts be customized? What language can they be written in? Please elaborate a bit on the admin interface available.
Oh, okay. Let's see. Is Tony? Are you on? Is Tony Chen on? I can't see the.
Yes. Looks like Tony Chen is on. We can.
Yeah. Can you let Tony answer that question?
Yeah. Let me. I think. Oh wait. Yep. There he is. Allow to talk. Here we go. Go ahead, Tony. Oh, you can. Oh wait. Unmute you. Yeah, you can go to unmute yourself, I think.
Yeah. Can you hear me?
Yes.
So yeah, the parser is programmed in Java language, and it's programmed according to the specifications of the beast and beast2. So the question about whether it's customizable depends on the data type, the data file that you're using. So it's not dynamic, it has to be programmed according to the specifications.
So basically it's a one-off, you know, like in one case there's a bash script and the other one it's a job. Are they both bash scripts that you're using to parse the output?
Yes, both are bash scripts, and also there's a Java portion of it, getting the file out of our database or the file storage and decompress it and parse it, feed it into the scripts. Yes.
And these are very specific to, I mean, these happen to be XML files that are coming in. So the one that's parsed directly, the other one has to be run through the job run, and we have to parse the output file of the job run. And so these are rather fragile, right? I mean, they're very specific to the output.
Yes, beast2s are more complicated than beast1, and beast2 has to, like you said, has to be fed into another Java library that provided by the community to do the pre-run and then get the output file and then get the data we need.
Okay, so if you have your own, if we're using this framework and we have codes that we want to do this this pre-processing, we could set up our own Java code for each of those tools. Is that the idea?
Yes, you will get the scripts, and then you get all the necessary Java libraries for the beast2. And then in your main body of the code, when a user uploads a file, then you will open up the file and then try to determine what format it is. And if your code determines that it is a beast1 or beast2, and then you feed it to the right scripts accordingly.
Okay, thank you.
Sure.
All right. Okay. And then in the final step, valid jobs get submitted to the host once they've been passed validation. And I wanted to talk about how submission happens. Our submissions run by a couple of daemons. There's a submit daemon and a load results daemon. Just a few words about those. The submission daemon will basically find new tasks. When a job is submitted, it's entered into the database in a running task table. So the submit job daemon will look for all new tasks, and then they will submit to the correct execution host, and they'll set their status to submitted in the running task table. And then on the execution host side, the daemon will authenticate, create a working directory, drop off the input files in a command line, and then they'll activate a custom script on the host. So there's a new script for each particular host that interacts with the scheduler. So each local host requires a script, and will receive this information and prepare a correct submission script. And we call that, in our parlance, submit.py is the script that we refer to it. So that's part of the yeah, it's not entirely generic. Each new host will require a zip-like. So yeah, just looking this over, the basic workflow then is the user submits their form, a parameter map is created and validated, and then a command line and a scheduler.conf file are created. Those are the input that are accepted by the submit.py script to create a proper submit script. Okay, and then the second daemon is called the load results daemon, which returns jobs once they're completed. Basically, it finds any done tasks, completed tasks, transfers the results back to the database, and then removes the job from the work queue, so it's flagged as completed. And this daemon communicates again with a custom script on the execution host, particular to that scheduler, to find the completed jobs, and then removes them, as I said, transfers them back and changes the status. Okay, so that's the basic function of job submission. And then the question is, how do we make tool addition and updating code scalable for our community? And a key part of our application is something we call the tool XML file. Each code or particular, I guess I should call it a tool, community codes, public codes that are parallel codes that we want to run all the command line options from. We specify those in this tool.xml file, as well as specifying how to create and populate the scheduler.conf file and any other auxiliary files that are required. And then so that generates validation at two levels. As I mentioned, there's a validation level in the web application, which is driven by JavaScript and then some by struts2, and that's all specified within the tool.xml file. And then on the back end, there's additional generated code for a second level of validation for when the job is submitted and populates the parameter map, and that goes through a second validation step. And so the ability to create these files allows us to have a high level of control over how command lines are created and submitted. And this is just a schematic to sort of give you an idea, basically, of how it works with the portal and with the REST service. So the tool XML is read in at compile time. We use a program called FreeMarker to convert the tool XML into a web form. And it also generates, as I mentioned, some validation on the struts2 side. And on the back end, in the Workbench framework and the SDK, there's a duplicate validation that occurs at runtime in the command renderer step. And for the REST service in Jersey, that's our REST application framework. There's a simulation of the piece specified controls and struts controls at runtime. Okay. Oh, and I said all this already, so sorry about that. Yeah. Okay. So this system of using these web forms is very good for making the things scalable. In their design, what they've done is made a somewhat rigid submission system, and it's designed to each new tool XML is actually linked to a single submit host in our current system, and we're revising. Well, that's historically how it's been done, and it worked okay for a long time, but primarily because one host has been enough for most of our jobs. We've run mostly on the common machine, and then sending serial jobs to the TSCC, the Triton cluster here at SDSC. But now there are situations we run into where it'd be really great to be able to submit to multiple machines. Sometimes the queue is deep, and or there aren't adequate resources on the machine we're using. And we found that submitting to an alternative machine or to the cloud would be nice. And there's a new machine called Expanse coming to SDSC. It'd be nice to choose which of those two machines we used, and it would smooth the transition from Comet to Expanse, the new machine. So we adopted as a goal developing code to allow submission to multiple hosts based on the job properties. Is it a CPU job, GPU job? What's the depth on the machines we're looking at? And Mark Zhuang in the group has taken that job on, and now we want to modify the SDK a bit relative to make it less rigid in terms of where we submit. Now, how will we do that? As I mentioned, like this is a pretty rigid system. It's pretty hard to modify the way we currently work to create the validation code. And so the issue basically boils down to the submission host for the tool XML is specified in the tool registry. So that's just part of the whole system, and refactoring that would be a bit hard. So Mark adopted the system of making the decision to whether to send the codes to AWS or Comet as late as possible after all that validation has been done, and beyond, you know, the situation where at compile time the tool XML and tool registry sets the information. And so he used JMX technology to modify the flags in the memory space of the application after all this is done, but before submission. So we can change the parameters without a rebuild being required. And so there's a new module now on the SDK called the resource selector. And the resource selector works like this. It evaluates the resource needs of the job to be submitted. It can pull the queues on the available host to see how deep they are, whether they're free, and then based on those two bits of information, it can specify the optimal host to submit to. And that way we could accomplish that without by writing it into memory, we could solve the problem of not having to refactor the entire XML validation system. Okay, so now the upside of that, of course, we can make the resource decision based on how busy the queues are, how many cores are needed, GPU or CPU, what type of GPU is optimal. And all those things are things that we worry about for any new code that we release. And I mentioned we managed to do submission to AWS as part of a project that happened over the last year that's now ended. But Mark was able to create a CIPRES Slurm scheduler using the AWS provided infrastructure that would allow us to gives us basically a meta scheduler, so we can send the job to a virtual cluster in the cloud or to an Exceed cluster, irrespective of the status of either of the two hosts. All right, the last step is user notification of status changes in the job or errors via the interface. And error handling is something we've thought about. We've got a system now where error messages from the submissions are, and we can bin them and just decide what kind of messages to give back to the user and modify the behavior of the application in response to certain kinds of error messages. So jobs that fail because the host is offline, in the past, the user would just get a confusing message that wasn't very user-friendly, and they wouldn't know quite how to respond, so they'd ask us for help. But now, when that happens, we take jobs that are recognized as the host being offline and retry them automatically for up to 48 hours, and the user can stop that retry if they wish. But at any rate, submission failures due to host failure or connectivity failures to the host are retried. Users are notified when their job time's out, so their job is restartable. They'll be told how to do it, and if not, they're offered an email address for help. Issues that are from a bug in the interface are reported to the user as well, with an invitation to request support rather than just giving them a naked error message they won't understand. Let's see. So controlling resource use, I mentioned that. The amount of SU use and data storage is configurable and can be set globally through an admin interface. And this is checked before each job submission. We need this information in real time, which isn't a problem for storage, but there is a 24-hour lag in SU reporting from the Exceed database. So we developed this system to help with that. So for each submitted job, we calculate and store the maximum possible SU usage for a running job. And then for a completed job, we calculate and store what our calculated SU charge will be from Exceed. And then we replace that value, or we add to that value the actual storage charge when it arrives. But because we want to control users in real time, we really need this information very quickly. And so for each user, we keep and display the sum of their possible and actual usage. And that's the sum of the maximal possible usage from any running jobs, our calculated usage for completed jobs, and usage charged by Exceed already. So, and once a job completes, obviously the unused time that was reserved for the run is released. Yeah, so mentioning the administrative interface that we have now, there's a couple of different options that it provides. It can give you system statistics to show jobs that are running, jobs in the queue. But it can also display any given user's jobs by username or by email or by a specific job number. And it can also allow you to activate users. When users register, they're required to respond to an email, and I can check their status through the interface and add them as users. If there are some cases where the email fails. All right. I'm a little low on time here. I'll just try to cover this quickly and we'll see what happens.
So far, you're good with questions. There are no other questions that have popped up yet. Okay.
So if people were interested in creating a workbench, I just wanted to show what is that going to be like for you. The first is the requirements page, which is, here's the list of the requirements. I won't read them. And then build a system. There's a build script, and then there's basically two parts. There's the generic executive infrastructure, which you won't need to change. And then there's the project-specific badging and information on the front end, and then on the SDK, there are project-specific tool interfaces and configurations, the tool.xml things that I've referred to. The build.properties file is a customizable file that specifies the location of all the resources. I think there's 33 of them. So it provides the address of those specific to the install. The build scripts provided, make and build the release, and then you need to create 5 directories, and those are listed here for various parts of the infrastructure. Let's see. Again, the tool registry, the tool XML files, which I'll mention a little more about in a minute, and then JSP pages for the web application and HTML pages for any static content. So that's the extent of creating it. Submission hosts, new resources, you edit a host registry, which is part of the tool.config file, which is the basic registry of all the tools and resources of it and hosts. You just simply define it as part of an XML format by a set of variables. I won't go through them. And then once the resource is added to the registry, of course, you have to install the tools and benchmark them on the remote resource. Create the PXML interfaces for the supported codes. Create the custom submit and cancel script, submit.py on the remote resource that interacts with the scheduler. and modify the CIPRES Workbench submit and results retrieval daemons to interact with your particular host. Adding new tools. New tools are a simple XML document, which I've described in some detail already. They specify the run configuration in conditional ways. And then the tools also specify, each tool is registered in the tool.config file, which is where the hosts are also specified. So here you can see the tool resources specified, but can be overwritten later according to the new system that we built. It uses the writes to memory. Anyway, jobs can be restartable. They can be cloud eligible if they can be sent to AWS. Those are known options. And also for job restarts, if a restart script is needed, if you need to modify an input file before a job restart, that provides that option. Customizing the web application, that's pretty straightforward. You could modify the CSS. You can add the new looking custom badging, and you can see here the Neuroscience and CIPRES gateways look very similar. Creating a static website, you need a static website. We use Expression Engine. You can use anything you want. You just need a landing place for when that web application is down, and help pages, contextual information for users, etc., and a place for REST users to get their documents. And here's our 3 different platforms that use this Workbench framework. So why would you do this? Why would you use our software? You need a functional gateway 2 weeks from today. You need to deliver command lines to remote HPC resources, and that's all. You don't need or want command line access for your users. You have a team with the requisite expertise to manage and maintain all the infrastructure. I think the maintenance part of this is relatively minor once it's set up, but you definitely need that expertise to get it set up. You don't mind supporting or have help supporting a server for your gateway. And a simple interface is what your users want. And our interface, I've gone to talks and apologized for our interface to our users and promised them I'd give them something better, and they always tell me don't change it. So it's a very primitive interface in my view, but we don't support a lot of interaction and social contact, but most people seem to really like that. So, all right. And these are the people who actually did all the work, so we'll just give credit where credit is due. Mark Zhuang and Tony Chen, who I've mentioned today. Alan Zhang is an intern from Torrey Pines High School, who's made some nice contributions. Alumni Terry Schwartz and Paul Hoover. Wayne Pfeiffer does all the benchmarking. Trevor Cooper and Dima Mission have done the AWS, helped us with the AWS work. And then from Exceed, Mona and Mahidar and Nicole have all been very helpful. And with that, I will conclude and say, I'll leave that up and ask if any further questions.
Right, so far there are no additional questions yet, but you're welcome to post your questions in Q&A or in chat. I'm monitoring both. Actually, what I'll do, Mark, is while we're waiting to let people submit questions, because that was very clear, I thought anyway, but I'm not technical, so it was really clear for a not technical person.
I'm not technical either.
Oh, well, you could have fooled me. So I'm going to share just information about our next webinar and all of that while people give some thought to any questions they may have. So I just want to remind you also, I put in chat that a link to our evaluation. And I also, whoopsie, I didn't mean to put, darn it. Somehow, oh, that's right, I know what I did. Anyway, so here you go. So let us know how this webinar was for you. Our next one is September 9th, and it's about Globus, automating research data management at scale. We'll be sending out announcements about that as we get closer. So thank you all for participating. And we do have a couple, we have a comment that just came in anyway. Kenneth says, just a comment that the REST API is very useful for a number of our users. I don't know if you want to comment about that at all or not.
Thanks, Kenneth. Kenneth, can you say, like, are your users using the REST interface through personal scripts, or is there an app that they use to access them?
Let me allow him to talk. Here you go. Okay, I'm going to promote you to a panelist because it says your version of Zoom is too old. So here you are, Kenneth. You can talk. And you can unmute yourself, I think. All right, maybe I can do that.
Am I on?
Yeah, you're on. There you go.
Actually, there are a number of ways that our users for NSG are using the REST interface. One is other gateways like Human Brain Project and Open Source Brain. They have their own gateway users. They're like a gateway of themselves. So they are just sending jobs through the REST interface to NSG. So they found that very useful. And they used a Jupyter notebook that used the REST interface to CIPRES Workbench Framework as the model of how to interact with our gateway. So I think they're finding that useful. But another model of using the REST interface is one of our MATLAB users. So they'll fire up MATLAB on their machine, and they'll play with their data, pre-process it there. But when heavy lifting is necessary for processing a bunch of data, they will package that up into a job and send it to NSG through the REST interface, and then get results back the same way, and then continue post-processing and data visualization on their machine with MATLAB. So I think the REST interface makes it very flexible to access HPC resources, but still have your the pre and post processing on the client side. Still able to do that.
Nice. And did your users, the ones who package it up like that after using MATLAB, are they pretty sophisticated, or did you have to give them a lot of help in packaging it up and sending it?
Not that much help. I think we just gave them an example of the curl calls to the REST API. And once they saw that, they were able to incorporate that into their MATLAB toolkit. It's a one-liner with the curl command to submit and run, to upload the data and run the job. So not too difficult.
Nice. Nice.
And I'll just clarify too, because NSG is the NeuroScience Gateway, which is one of the gateways using the CIPRES Workbench. So for those who might not know what the context is for this, I know that's a very actively used gateway. Yeah, thank you for joining us, Kenneth, and commenting about that. That's really helpful to know. And I'll add that if those of you who are thinking about coming to our conference, I know that MATLAB is hoping to present a learning lab talking about some of their tools that help people work with gateways or things that can be used in gateways and so forth. So that's something to check out, which will be announced later after registration gets going. I don't see any other questions other than someone who wanted to get the slides and recording, and that will be posted in the next few days. And since it's the top of the hour, I'm going to say thank you, Mark, so much for presenting this. I found it really helpful just even to have the comparison that you offered at the beginning about, how different gateway platforms approach the task and how yours fits into that broader scheme. Yeah, that was very helpful. So thank you so much, and thank you all of you in the audience for joining us today and expressing your interest. I hope you'll also check out other parts of the series, which is now a 6-part series about gateway platforms. So we look forward to seeing you again next month, and I hope you have a good rest of your week.